At Simul8, we think machine learning is useful for a few reasons. The first is going to improve accuracy. There's no misjudgment from the data at all. The data that you need tells the story of your process, and it includes all the niche rules that make it work. It's also easily maintained as your process changes. All these changes will then be reflected in the data, and you don't need to rebuild your simulation. It is a case of just retraining the machine learning algorithm with this new data, and the simulation will do the work for you. And then finally, it's going to save you time. As processes become more complex, data becomes more vast, becomes more difficult to understand. It's taking longer and longer to analyze and understand all these rules in the process. And by definition, machine learning is simply an imitation of these rules in your process. So you don't need to spend the time doing the analysis. Machine learning is going to do that for you. And you're going to get to ask the what if questions even quicker. Also, building a simulation is iterative. We've always said from the start, or we've always said to start simple and add. Create these simple simulations as simple as possible, but as complex as necessary. And each time you go through one of these iterations, you need to verify your changes, make sure the logic's working as you expect. Where we see machine learning of being use is around this kind of verification and validation stage. As the rules are sort of built into the process from your data, your simulation is going to perform exactly as your data is telling you to. And this verification validation process is going to speed up as well. And finally, you really don't need to be an expert to do this at all. All you need is some data which is reflective of your process to build these algorithms in quite easily. First of all, I'm just going to show some of the data. So this is of a paint line process. We've got some transactional data here where we've got things like product type. So we've got 3 different cars, when they entered and exit the paint line, what color they were painted, whether there was any changeover or whether it was rework. And we've also got the time that they took in this particular process as well to be painted. Now, to do this at the moment, we have to create some distributions. So I've got one for my changeover time that was impacted on our process time. And I've got a distribution that just calculates how long they spend in the spray booth as well. Now, there was a few other factors that we had to take into consideration, and I have to write some visual logic to do this. So you can see that we're sampling the spray time. We've got this time where we spend slightly quicker at the start of the day, slows down towards lunchtime, and then speeds up towards the end of the day. So we're having to take that into consideration. We've then got our changeover effects in here as well, and then our rework in here. I'm not going to go into the visual logic in detail, but we've got a few lines there that takes all these different components into consideration when actually calculating the spray time. So that's what we can do at the moment, but we want to make this slightly easier, and we can use machine learning to do this. So if I just open up my machine learning example, then we can have a look at the difference. So straight away, if we have no visual logic in here, so we can keep the simulation nice and clean. There are a couple of distributions. So I've got still got my product mix, the types of cars that are going through, but I've also got a new distribution in here as well, which is looking at sort of sampling from machine learning algorithm. So if we have a look in here, then we can see some of the parameters that we're going to add in to our distribution. So first thing we're looking at is my R script. So I have had to create a script that's going to read in my data and understand how to then apply it to my machine learning algorithm. And we can have a look at this in here. So we've made the connections as easy as possible from Simul8 to R, and it will produce the parameters from the simulation into a data frame. So we just need to read these parameters in, and I've saved my algorithm as an RDS file. I'm reading that in and just then returning the prediction from that neural net in this case. But it could be anything. It could be a decision tree. It could be a random forest. or it could just be a simple distribution as well. So we're reading those parameters in, doing the prediction, and then that's what Simul8's going to then use as the timing. Now, the parameters that I'm passing through are some of the parameters that are highlighted when training the neural net. In this case, it's to do with the product type, so the different types of car that are being sprayed. We saw from the data analysis that the hour of the day also had an impact on the processing time, on the spray time. So we're taking the simulation time. We knew things like changeover was also another effect of that, and changeover is impacted by the color that the current car has been painted, but also the color that the previous car was being painted. So I'm storing this from a label, and the previous color has been just stored in a spreadsheet. And then rework was the other final parameter that affected the time, where if a car was being reworked on, if it had failed that inspection, then it was going to speed up the processing time. So we're taking these 5 parameters in, and as I say, Simul8 then puts them into a data frame, R reads them in, and then does that prediction for us. Setting my timing distribution to my machine learning distribution from the drop down here, and then we can run it through. So the first time it's going to open up R and call this script, and then once it's done that, it's just going to run the simulation as normal. So let's just pause it here, and we can have a look at the work item. So this work item is our SUV. It's color blue, and it's not a rework. And we can have a look that it's going to take about 45 minutes or so to then process this particular work item, which was in line with our data as well. And that's all we need to do.